Hello again, and welcome back to Wingot Plays Nomifactory. I was setting up an area over here so that we could put our new MV machines and start playing around with them. As part of that, I've run a new vibrant capacitor bank, which is the final tier of those capacitor banks, and a high energy cable. I've even run some ME cabling so that we can have access to our whole system, all of our storage except for the drawers for now from this system. And then I was going to set up a MV CEF so that we could get the power into the system from the RF power that we've got there. And that's when I ran into the MV machine hull. Obviously, I've made one of these before because I made the advanced chemical reactor. But the MV machine hull can be made either with this manual process, using a couple of wrought iron plate, aluminium plates, copper cables, and MV machine casing, which then uses the wrench there. As I said, manual process with a consumable tool. Or you can make it in the assembler, which uses an MV machine casing, a couple of copper cables, so the same as this bottom row, but none of those plates. What it does use instead is this here, polyethylene, to then make the MV machine hull. As I've said before, in fact, I think at the very start of this whole series, I much prefer to the automation way of doing things. And so if there is an assembler recipe here that can make the MV machine hull and save us on a few resources while we're at it, then I'm going to go for that option. But in order to get that option, the MV machine casings can also be made in the assembler with just aluminium plates and an integrated circuit, so nice and easy there, no fluid required. But the MV machine hull needs polyethylene, which is something that I've been putting off for quite some time. I've had a little bit of look into it. I figured I'd bite the bullet, and the polyethylene can be made in the chemical reactor with ethylene and air. Air doesn't have an obvious way to obtain here, but I found that there is this basic air collector, which, when provided with a bit of power, just starts collecting air inside of it. And so I gather you should be able to hit that with a wrench, export from the basic air collector into the chemical reactor, and fulfill that requirement. The other thing we need is ethylene. Ethylene can be made from various single fluids in a distillery, or none of which I'm particularly aware of. Maybe we've got access to some of these, but I've not looked into that yet. If we look at a chemical reactor, ethylene can be made from ethanol and sulfuric acid, and produces diluted sulfuric acid as a byproduct. The diluted sulfuric acid can be converted back into sulfuric acid at a 3:2 ratio, so that should then feed back into the system, and we can always void in a fluid trash can if we need to any excess. But the ethanol can be made in a distillery or in a distillation tower, but in a distillery, which is a single block, and so we'll do that to start with, you can convert biomass into ethanol. And finally, you can get biomass from in a brewing machine with water and saplings, or sugarcane. We've already got an infinite source of sugar, so how about we just convert that sugar that we're already getting into biomass? And then the other thing we need, sulfuric acid, which we can obtain in the chemical reactor with a bit of water and sulfur dust, which we've already made. So this will at least allow us to get started on the process of making polyethylene, which we can then feed in order to do our MV machine hulls. I'm going to get to work on that, and I will see you in just a minute. And I now believe I've made all of the machines I'm going to need to get this set up. Here, this basic chemical reactor should convert ethylene and air into polyethylene. This chemical reactor should convert ethanol and sulfuric acid into ethylene and diluted sulfuric acid. On top of that one, we can put a chemical reactor which will convert water and sulfur dust into sulfuric acid. And then to feed into this chemical reactor, we can have the distillery, which is fed from a brewery. And just to fix that up, we will also need a conductive iron cable on the back, providing energy to that brewery. Perfect. So we've now got all of our machines here. We also will need a power cable at the top there. And while I'm at it, let's go grab, where did I put here? The air collector. So we want the air to be output, into this chemical reactor here. So we'll give it power, because all these machines love power. And then this guy also wants water. So we've got infinite water sources, so let's use that for now. We'll see how well it runs. If I need a better infinite water source, I can always run power fluid cable from the end of wire. But for the time being, how does it go if we just feed it with water from there? Because I think it's actually fairly slow recipe. Some of these were like 52.5 seconds or 60 seconds to actually do their particular recipe. Now, at this point, we also are going to need water in this machine here. So we'll quickly just grab another infinite water source while we get things set up. Perfect. The first step here is water plus sulfur dust, which should, sulfur dust plus water in a basic brewery, okay, I think this one's, oh, my mistake. This sulfur dust goes up into this machine up here, the chemical reactor, which should, chemical reactor, sulfur dust plus water, 30 EU per tick, so it's less than 32. This should be able to run. It'll take 57.5 seconds, but it's going to use 2 buckets of water. That's what the problem is. We're just waiting on that to build up to 2 buckets before the process will start. And these infinite water sources produce 1 millibucket per tick, so they produce 20 millibuckets per second. It now has 2 liters in there, 2 buckets. I feel like that should be working. Sulfur dust S. I wonder if that's sulfur dust S, water, 2 buckets. It seems like it should be, there's no power. Now that it's got power, there you go, it's actually running. Always screw up the power. And then pop over here, grab some sugarcane, because sugarcane plus water over here in the brewery should then make us, sugarcane water makes biomass. Now, we are going to need our wrench so that we can configure these machines to feed into each other. This guy, this air collector, we want it to feed into this chemical reactor below it. So let's try hitting that. That doesn't seem to work. So is there a fluid cable that I could use to pull out that air? I'm not quite sure how this is meant to work. But let's try moving this air collector up a step, put a fluid conduit here and disconnect it from these others, and then put the air collector there, always extract, insert into there, and it's going to need power. Let us give this a go. And then that's putting air in. Fine. So air works as a fluid. It looks like maybe just hitting that with a wrench doesn't allow it to output to that side, and the air collector doesn't seem to have a GUI, so I can't go into it and tell it to output its fluid. But that pipe at least seems to work. We've got sulfuric acid coming into here. If we tell it to output the fluid goes down there. Perfect. In here we've got biomass being produced. If we tell it that it can output, the biomass will go here into the distillery, and then it needs a configuration 0 integrated circuit plus 1,000 biomass. It's only got 500 at the moment before it will be able to run. So if we configure this, configuration 0, and just wait on the biomass, then that should convert into ethanol. 1 bucket will become 700 ethanol. And then in here, the sulfuric acid, along with 1 whole bucket of ethanol, will make ethylene. So let's just going to have to wait on this process. Meanwhile, you're doing fine. And once we do get to this stage, we're going to need MV machine casings, which is just aluminium plates, which I think we've got those sitting in here, yes. And so these aluminium plates can go into there, and then they also need a circuit set to configuration 8. So if we grab one of these and set it to 8, place that in there, then that will create our MV machine casings, which will then feed back into the system along with copper cables. Copper cables we can easily get. In fact, we've got copper wires, so if I grab a full stack of those, I don't think we've got a stack of plastic in here, but we can easily make plastic by grabbing this rubber. I'll do another stack while we're at it, and feeding it here. I'll do 3 stacks, that's fine. And when that's ready, we'll be able to feed it into here. So we've got 8 MV machine casings. How are you going here? We made ethanol. It's going to need to run again before that ethanol will actually be usable, but we'll put it in here into ethanol plus sulfuric acid. And then, yeah, that's just going to take time. This is probably already finished because the rubber sheet creation is quite quick. And then you are just going to need normal 1x copper cables, which is what I have in my inventory. So if you put those into there, then once this gets the polyethylene that it requires, it will be able to craft. And just going, I think it's probably best that I just ignore the creation of the ethylene for the time being and come back to it in a moment. For the time being, the inscriber is, we may as well get started on the other components of the inscriber here, which we're going to need for applied logistics to move it into the next level. As you can see over here, we got all of the inscriber plates by I went out, while I was out hunting, I found a few meteors. I dug to the middle of those meteors, and in the middle there's a skystone crate, and they contain the various inscribers. I found 2 different meteors between them. I got all 4 of the inscriber presses. We're now going to need an inscriber to be able to make the various processes which are then required for the further steps. So let's look at making an inscriber. The dark steel, I don't think we've got any dark steel there, but I do think I told this system over here to make some dark steel for us. Perfect. And off memory, I think it said I'm going to need 5 dark steel plates. In here, the electric pistons and electric motors, I think I have already previously... Oh, okay. I have previously made those, but apparently I only made as many as I needed. So what I'm going to need to do is get some more copper cables, some copper wires, and then some magnetic steel rods and aluminium rods to make more of those. Alternatively, what I could do, I could make these in an assembler, but apparently the electric piston MVs can only be made in a crafting grid. There isn't a tool involved in that, so this is something that Applied Energistics will be able to automate, but I'll still need 1 magnetic steel rod. Let's see, let's look at this. It looks like it's probably about the same, except it uses only half as much copper. It's probably easiest at this point just to make a batch of these electric motors, but by now this will have run a second time, and we've got a litre of ethanol there plus sulfuric acid, which I feel like should actually be running. A litre of ethanol plus a litre of sulfuric acid, 120 EU per tick. This is going to have to be an advanced chemical reactor in order to do this process. So, which I won't be able to power with this cable here. Okay, going to have to come back to that later. To make even 1 advanced chemical reactor will require us to make another chemical bath reactor. Will require us to make another MV machine hull anyway. So it looks like we're going to have to make that manually for the time being. So let's grab, we've got the MV machine casings at least, and then we're going to need 8 aluminium plates and 16 wrought iron plates. So 8 aluminium plates is easy, and then wrought iron, 16 of those, which will allow us to convert all of these MV machine casings into MV machine hulls, and then we can make 8 machines from what we've made so far. That is actually rather annoying, because it was so close to being a working system. And I'd even checked the EU requirements on most of the steps, and obviously had just overlooked that 1 machine there. Still, that's how this game often goes. Additionally, once we've got this MV machine hull, we'll be able to use it to make that inscriber, and that will allow us to get started with Applied Energistics, to expand our Applied Energistics to being more useful. In the meantime, we need those, we need these, we need these. Yep, and then we're just waiting on the wrought iron. Quickly just going to put these plastic sheets away while we wait. electronic circuits, I don't think we need those on us at the moment. Sulfur dust, we don't need those on us at the moment. And this basic chemical reactor may as well go away because we're not using it. How did those go in there? And then just waiting on the wrought iron plates to finish. It wouldn't be a Wing Got Plays episode if I didn't screw something up at some point. Perfect. Now, if we look here, the MV machine holes, let's make that. The CEF is going to require energetic cable, which energetic alloy wire. Let's look if we've got any. We don't, but we can easily make it. It said we were going to need 2 4Xs, which this 4 ingots will allow us to make. We're going to need energetic alloy conduit, which was on the screen there, but I pressed delete before realizing. We're going to need a circuit, and we are going to need a chest. Oh, which we are out of chests, so we'll go grab a stack of wood and make some more chests. That allows us to make the 2 4X energetic alloy cables that we need. And if we grab a stack of wood, in fact, let's grab 2 stacks of wood, we can make a whole stack of chests. Put those away, and that should be everything we need to make a CEF. Oh, it's the processor, not the circuit. Okay. Which is here. Perfect. So now that we have a CEF, we can put that over here. And it will then provide MV power to our system. I'm just going to look if we have another flux capacitor. We don't. What I could do temporarily is grab our personal one and put that in here and just look to take that back out later on. In the meantime, if we put some energetic alloy cable, I think I don't like the positioning of this. Let's pull it over one more. And there. Which means we just need to move that and put one more power cable there. Perfect. So now we can make MV machines and basically replace a lot of our LV machines there with some MV machines, just feeding off of the power system as we've already got it set up, which is all pretty nice. But if we take a look here, from an MV perspective, I think what we want to do is get an inscriber up and running. We've got the MV machine holes now, we've got dark steel in our inventory, we just need to make the plates, and the plates are there, and then we're also going to need the electric pistons. If we just quickly go to our, we need a fluix crystal, our terminal here. Oh, I've got that flux capacitor still on me. Oh, it's fine. There's no machines hooked up there. And to make these electric pumps, I'm going to need electric motors. So I need magnetic steel rods. If we grab just a bit of normal steel, let's just make 16 for now. And that'll make us 32 steel rods. In fact, let's make 16 steel rods. Perfect. We need aluminium rods. And we need double as many of those as we have of the steel. We also need aluminium plates. Sorry, we need copper cables and copper wires. We need 8 copper wires for these and 2 more for those. So we need 10 copper wires and we're making 16 magnetic steel rods. So in total we need 160 copper cables. If we don't have all that much in the system already, so we've got practically infinite copper. Let's make some more. So if we need 160, then that means we need 80 of these copper ingots, because they'll double as part of the process. So 64 plus 16 is 80, which will allow us to make the copper wires that we need. Perfect. And then that should be everything we need here. We just need some copper cables, but we've already got the plastic sheets. Now for the next step up, we need more copper cables. If we're making 16 of these electric motors, and let's change that in there, we've got a polarizer over here which magnetizes our rods. Pretty cool. But yes, if we're making 16 of these motors, let's make 8 electric pistons. I'm sure that we'll need more than that in time, but for now we'll just make 8. So to make 8, we're going to need another 8 aluminium for those rods, and another 24 for those plates, and we're going to need small aluminium gear. So those look like it's 1 ingot to make 1 small aluminium gear. So we're going to need 8 of those, and we're going to need nothing else. That should be everything we need. If we look in here, I have a small gear recipe. Let's take that mold out, put that mold in, and then melt up 8 aluminium ingots, which is an MV recipe. So the question is, there was also an alloy smelter recipe here, which uses an aluminium ingot and the small gear to make it, and that's a low voltage. So let's grab this, put both of those into there, and that one will at least run. We also needed 16 more of these aluminium rods, and we needed 24 more plates. So that should be making all of the aluminium that we need. We, over here, now have our 16 magnetic steel rods, and we should be able to go in here and make... We need to... How many of these do I need? 30. I need 4 of these per magnetic steel rod. So this will only make 32, so I still need another stack. Well, one more stack of 1 times copper wires to make another half stack of 2 times copper wires. And that's done. So if we grab those, perfect, and then we can make the electric motor LVs. Got 16 of those, and now we're just working towards making the 8 of these electric pistons, which will use 16 copper cables, which conveniently is actually what we have in our inventory. So we're not even actually going to need these copper wires, unless I'm forgetting another step. If we go here to the lathe, there's our aluminium rods, and now we're just waiting on our aluminium plates, and here we've got our 8 small aluminium gears. Pretty cool. It's getting pretty close to being done. I don't think we need these copper wires at all. I'm just going to put those away. And we're getting pretty close. Perfect, done. Now that will allow us to make the 8 electric pistons, MV, and we should be able to make an inscriber. Cool. The inscriber, if we connect that here, allows us to it uses applied energistics power, although strangely it doesn't seem to be getting power. I don't know if maybe it needs a recipe in it before it can get power. Otherwise I'll need to go looking to see what's going on. But let's put away this extra stuff that we've got here. And what we need to do, claim that, is we need to make these various processes. Let's start with the calculation processor. And the process for that one is we need a printed calculation. We need a refined circuit or an electronic circuit. We've got electronic circuits in here. We've only got 12 left, but let's try to convert. We need printed silicon. So printed silicon, we need a silicon plate. All we have here is silicon dust, which, let's take a look here. Silicon plate can be made in the compressor from silicon ingots, which is probably the process we're going to have to use. But how do we... Oh, we can convert silicon dust into silicon ingots. So let's just do 16 of these for now. We'll smelt those up. And that'll allow us to get the printed silicon. The printed calculation circuit needs Certus quartz plates. So that just needs Certus quartz dust or the GregTech Certus quartz. I don't think we've got any of the GregTech Certus quartz in here, but we might be able to make the Certus quartz dust by pulverizing these Certus quartz crystals that we've got here. So let's grab 16 of those. We'll pulverize those. And then use the compressor on that dust to make the Certus quartz plates. Compressor over here. Perfect. We've got here silicon ingots, which need to become silicon plates, so they also need the compressor when it's available. And we're also going to make 16 here of these Certus quartz plates. I'm just going to quickly pause here while we wait for these to process, and I'll see you in just a moment. And now that we've got all of the components that we need, if we head over to the inscriber here, this recipe requires printed calculation circuit, printed silicon, and refined and a circuit. In order to get the printed version, we need to put in a silicon plate and the inscriber silicon press to get the printed silicon. We're going to need quite a few of these, so I'll make like 4 for now. And unfortunately, with the most basic version of the inscriber here, we can only do 1 at a time. With the advanced inscriber, we'll be able to do full stacks, and we'll also be able to automate the process. But the calculation press with the Certus quartz plates allows us to make printed calculation circuit. If we grab, let's just grab 4 of each of them. Perfect. And then when that's done, we'll grab out this calculation press. We need both of those plus an electronic circuit in order to make a calculation processor. Perfect. Now this calculation processor is used in a number of the different recipes, but one thing that it's used for, if we grab these, let's put this Fluix cable back because we'll need it in just a sec, but ME terminal plus calculation processor plus a crafting table allows us to make the ME crafting terminal, which is the same. We can still access things through the system, but it also has this crafting grid here. And this crafting grid, if we, let's say here, a block of redstone, we'll put that there. And so it's saying, convert 1 block of redstone into 9 redstone. When we click there, we've got the 9 redstone, and it's taking it out of the system in order to do the recipe that we've said to do. So this allows us to craft using the contents of our applied energistic system, wherever they happen to be. Pretty cool. I tend to love these crafting terminals, and now that I've got this, I probably will put away our handheld crafting table, and I'll replace all of the terminals that we have with these crafting terminals, which will mean that we don't need to grab the items out when we just want to craft with them. We'll be able to just use the stuff already in the applied energistic system. Unless, of course, they need the various machines, but even in time, we will get to auto crafting, and with auto crafting, we won't even need to take the items out of the machine, out of the AE2 system. They will automatically feed into the various machines. But that's getting ahead of ourselves. It's hit the end of this episode. So stay healthy and happy, and I hope to see you in the next one.